Hello everyone. So I've already given you a brief introduction regarding the probability. Now, as it is the light episode, I'm only planning to take some of the very simple problems and some of the basic facts regarding probability, which is essential throughout the chapter. So we can go to the topic directly without any delay.
Before going to the topics in detail, I need you guys to know about 5 basic facts of probability, which is going to be extremely helpful and useful for you throughout the chapter and episode. So the first point is probability of an impossible event is zero. An impossible event means an event that cannot happen. For example, if I say tomorrow sun is going to rise at west, we all know that it's not going to happen for sure. So such an event is called as an impossible event, and probability of an impossible event is always zero. Now, second point is probability of a sure event is 1. A sure event means an event that will certainly happen. For example, if I say tomorrow, after the day we are going to have a night, I know it sounds silly and funny, but surely it's going to happen. So such an event is called as a sure event, and probability of a sure event is always 1. Now, third important point is an event with a higher probability is more likely to occur. Remember the example which I mentioned to you during the intro section. If a doctor is coming and saying to a patient, that is, the chance for you to survive this surgery is 90%, which means that doctor is coming to say that there is a higher probability existing in the case of patient. So we have to understand that if there is higher probability, then that means the chance for that patient to survive or the chance for that event to take place is higher. And if the probability is lower, then the chance for that event to take place will also be lower. So that's the third point. Now, fourth point is probabilities are always between 0 and 1. I already mentioned you 2 extreme cases of probability. So one extreme case is actually it is an impossible event which is not going to happen for sure with a probability of 0, and the other end it is a sure event which is certainly going to happen with a probability of 1, which means that if you are asked to find the probability, you should essentially get a value in between 0 and 1. And if you are not getting a value within this range, which means that if you are getting a value more than 1 or less than 0, that means there is a high chance for your answer to be wrong. So if that's the case, try to do 2 or 3 times to make sure you are doing it correctly. Now, last point is probabilities of all different outcomes must sum to 1. Imagine there is an experiment and it is having totally 4 possible outcomes. So the total value or the sum of the probabilities of all these 4 possible outcomes should be 1, which means that if you are adding up the probabilities of all the 4 outcomes of that experiment, you should get the value as 1. The last 2 points you will get to know more in detail after doing some problems. Okay, so just remember the fourth and fifth point because it's going to be helpful for you, and we are going to get to know it more in the upcoming sections by doing some problems. Now, finally, the most important point, the equation for probability. So P of E or P of experiment is equal to number of outcomes favorable to E divided by number of all possible outcomes of the experiment. So it is just a ratio. In the numerator side, you have to think about the number of outcomes unfavorable to the event, which means that if you're asked to find the chance for getting ahead means try to find how many possibilities are existing for getting ahead. So that value should be your numerator. Now denominator is the number of all possible outcomes of the experiment. So when you're conducting that experiment, if there are 5 possibilities, then that is the value you should put in denominator. Or if there is totally 10 possibilities existing, then you should put that value in the denominator side. Now we are going to the problems. So our first question is, what is the probability of getting ahead? So we know that when we are conducting the experiment of tossing a coin, there is only 2 possibilities existing. Either you can get a head or you can get a tail. So when you're asked to find the probability of getting ahead means that in the numerator side, we need to understand that there is only one possible outcome that is in favor with getting ahead, which means that in numerator, we have to put the value of 1. And when it comes to denominator, we have to think about all possible outcomes of the experiment, which means that I've already mentioned there is only two possible outcomes. So that means we have to put a 2 in the denominator, which means that probability of getting ahead is 1 by 2, or you can say it as zero point 0.5, or in percentage, if you want to represent it, is 50%. Now, probability of getting a tail, we are going to find in exactly the same way how we find the probability of getting a head. So here, probability of getting a tail means that in numerator, there is only one possibility existing in favor of getting a tail, which means that we have to put 1 in the numerator, and total possibilities is again 2. So we are going to put a 2 in the denominator. I hope you still remember the fifth point which I mentioned in the last slide, that is, the sum of probabilities of an experiment should be 1. So here I've already told you there is only two possibilities existing, and we have already find the probabilities 2. So when you are summing up both of this value, you should get 1. So zero point 0.5 plus zero point 0.5, it is 1. Or 1 by 2 plus 1 by 2, it's again 1. So I hope you understood this point. You have to remember this fifth point very importantly because it's going to be extremely helpful for you throughout the probability. Now, the second question is, a bag contains red, blue, and green balls. If a ball is taken randomly, what is the probability of a red ball and what is the probability of getting a green or blue ball? So when you are conducting this experiment, that is, a bag is containing three colored balls, one is red, blue, and green, which means that if you are randomly selecting a ball, there is only three chances existing. Either it could be a red one, or it could be a blue one, or it could be a green one, which means that conducting experiment, there is only three possibilities existing. Okay, and now we are asked to find the probability of getting a red. So probability of getting a red means in the numerator side, we know that there is only one possible outcome in favor to getting a red ball. So that means in numerator, we have to put the value of 1. Now, when it comes to denominator side, we know that there is three possibilities existing. That means you have to put a 3 in the denominator side. Now, the second part is probability of getting a green or blue ball, which means that if you're getting a green, you're okay. And if you're getting a blue, it is still okay, which means that there are two possibilities in favor. So that means in numerator side, we have to put a value of 2, which means that even if you get a green or even if you get a blue ball, still it's fine because we are asked to find the probability of getting a green or blue ball. So that means there is two possible outcomes that is in favor with the situation. So that is 2 in the numerator, and total possibilities is again red, blue, and green, which means that three outcomes are possible in total. So that means we are going to put a 3 in the denominator side. So we are going to the next problem without any delay. Our next question is, upon throwing a dice, what is the probability of getting a number less than 3? What is the probability of getting an even number? Probability of getting a 7. You have to first understand the fact that when you're throwing a dice, there is 6 possibilities. Okay, I hope you remember the dice. Okay, this is commonly being used for playing snake and ladder, and I've also seen it being used for playing Ludo. So when you are trying to put a dice or throw a dice, there is only 6 possible outcomes existing. That could be numbers from 1 to 6. That is 1, 2, 3, 4, 5, or 6. So these are the all possible outcomes of rolling or throwing a dice. Now, first question is probability of getting a number less than 3. So we have to see how many possible outcomes are favor with this condition. Number less than 3 means that there are only two possibilities, that is 1 and 2. So probability of getting a number less than 3, that means there is only two outcomes possible. So in the numerator side, you have to put 2, and denominator side, you have to put the total number of outcomes, that is 6 possibilities, so we have to put it as 6. So that means 2 by 6. Upon simplification, you will be getting the answer as 1 by 3. Now, second question is probability of getting an even number. And in this experiment, there is only 3 possibilities in favor with the condition mentioned over here, that is even numbers. So in this experiment, the even numbers are 2, 4, and 6. So basically, it is asking the probability of getting 2 or 4 or 6, which means that there is 3 possible outcomes in favor with the condition. So that means we have to put a 3 in the numerator, and in the denominator side we have to put the total possible outcomes, which we already found. It is 6. So in the denominator side we will be keeping it as 6, and that means we are getting the answer 3 by 6. Upon simplification, it is going to be 1 by 2, or otherwise you can say there is a 50% chance existing for this condition to be met. Now, third important problem is probability of getting a 7. We already know that there is no 7 in a dice, which means that doesn't matter how many times you are rolling the dice or throwing the dice, you are not going to get a 7 for sure. So that means the probability of getting a 7 means it is an impossible event, and the probability is 0. So the event is impossible and probability is 0. Now we're going to the next question. Our next question is, two dice are thrown at the same time. What is the probability that the sum of the two numbers appearing on the top of the dice is 8, 13, less than or equal to 12? So in previous case, it was easy for us because there is only one dice and we know that there is only 6 possible outcomes existing. But in this case, the things are a bit complicated because we are going to throw two different dice at the same time, which means that we have to start thinking about all possible outcomes you can get by throwing two dice at the same time. So if you are going to write down these possibilities randomly, you're going to get many different possible outcomes like 1, 2, 2, 1, 3, 1, 3, 3, 4, 4, 4, 2, likewise many. But that is not the way of doing, because if you are going to do in that way, you're going to take a lots of time and you are not going to find all possible outcomes. So there is a constructive way of doing this, which means that imagine you are going to throw two dice and you got one for the first dice, and we are going to assign 1 to 6 values for the second dice. So if you are going to consider this condition, you are going to get 6 different outcomes like this. So starting from 1, 1, we are going to 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Now, in the second case, we are going to consider that the first dice is getting a value of 2, and we are going to assign 1 to 6 values for second dice. So considering that condition, we'll be getting another 6 possible outcomes. So this is how we are writing 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. Similarly, we'll be assuming the values for the first dice as 3, 4, 5, and 6, which means that for every condition which I mentioned to you, we'll be having 6 different outcomes, which means that in total, we are going to get 36 different outcomes for throwing two dice at the same time. So this you have to keep in your mind for doing the rest of the problem. So now we are going to solve the rest of the problem one by one. So the first part of the question is probability of getting an 8. So if you want to find those combination that is going to give you the sum of 8, we need to consider all the possible 36 outcomes. So when you're considering that 36 possible outcomes, you can see that in the first row, we are not having a single combination that is giving you the sum of 8. The highest possible value you can get in this combination is 1 and 6, and the sum is 7. But you will not get an 8 in the first row. But in the second row, the last combination of 2 and 6 will give you the sum of 8. And in third row, we are having 3 and 5. In fourth row, we are having 4, 4. Fifth row, we are having 5, 3. And sixth row, we are having 6, 2. All these possible combinations are going to give you the sum of 8. There are in total 5 possible outcomes or 5 possible combinations that is giving you the sum of 8, and all that 5 possible outcomes are colored in green color for better understanding. So that means there are 5 different possible outcomes in favor with the condition that is getting the sum of 8. So that is favorable outcomes are 5 and total possible outcomes are 36, which means that in the numerator side we are having 5 and denominator side we are having 36. Now the second question is probability of sum, that is 13. That is quite interesting one, because the highest possible sum you can get at the time of throwing two dice at the same time is going to be 12, which means that highest possible number on a dice is 6. So even if you calculate 6 for both dice, you're going to get a sum of 12. That means you're not going to get a number greater than 12 by throwing two dice at the same time, which means that there is no single outcomes that is in favor with the condition, which means that it is an impossible event with a probability of 0. Now the last one is probability of a sum less than or equal to 12. So when we are examining these different 36 combinations, we can see that every single combination, if you add, you're going to get a number less than or equal to 12. The highest possible is 12 and lowest possibility is 2, which means that all these possible combinations are only going to get a number less than or equal to 12. That means the number of favorable outcomes in third case is 36 different combinations, or all the 36 combinations, which means that in numerator side it is going to be 36 and in denominator side it is going to be 36 also. So that means 36 by 36 it is going to be 1, or otherwise it is a sure event with a probability of 1. Now we're going to the last question. Our last question is, a box contains 5 red balls, 7 blue balls, 10 green balls, and 12 yellow balls. So first you need to find probability of getting a green ball when a ball drawn randomly. Second one, what is the probability of getting a red or blue ball when a ball drawn randomly? And third one is probability of not getting a yellow ball. So first of all, if a ball is going to be drawn from a bag or a box randomly, you have to understand that that particular ball could be one of the 5 red balls, or one of the 7 blue balls, or one of the 10 green balls, or one of the 12 yellow balls. It could be any of them. So we need to find the total possible outcomes first, and in that case you need to sum up the total number of balls, which means that you need to add up 5 plus 7 plus 10 plus 12. So total number of balls is going to be 34 after finding the sum of 5, 7, 10, and 12. Now we need to find the probability of getting a green ball in the first question. So we know that there is only 10 green balls within the case. So the favorable outcome satisfying the condition of getting a green ball, there are 10 possible outcomes. So that means favorable outcomes are 10 and total possible outcomes are 34, which means that in numerator we need to put 10 and denominator we need to put 34. And upon simplification you are going to get 5 divided by 17. Now second question is the probability of getting a red or blue ball, which means that we are okay with getting a one of the red balls or one of the blue balls from these 5 plus 7, 12 possibilities, which means that our favorable outcomes in this case is the sum of red balls and blue balls in total. That is, we are okay with getting a red or blue ball. So the favorable outcome satisfying this condition in the second question of getting either red or blue ball is 5 plus 7, that is equal to 12. That is, the favorable outcomes are 12 and total number of balls is 34. So that means in numerator we are going to put this 12, and in denominator we are going to put the total number of balls, that is the total outcomes, that is 34. So upon simplification you are going to get it as 6 divided by 17. Now last question is going to be a bit tricky, which means that we are asked to find the probability of not getting a yellow ball. Not getting a yellow ball means getting a red, blue, or green balls, because in that box there is only 4 color balls in total. So not getting a yellow means it should be a ball that is having a color of red, blue, or green. So favorable outcomes in this condition is the sum of red, blue, and green balls. That means if you're adding up the total balls in red, blue, and green colors, you'll be getting the sum as 5 plus 7 plus 10 is equal to 22. Total balls we already know it is 34. That means the numerator we need to put 22 and denominator we need to put 34. That is, after simplification, you are going to get 11 by 17. There is one more way you can do this same problem. Okay, we are asked to find the probability of not getting a yellow ball. How about finding the probability of getting a yellow ball and subtracting that probability from 1? Because we know that as per the fifth condition, which I mentioned to you, the sum of all possible outcomes probability is going to be 1. So if you are subtracting the probability of getting a yellow from 1, you are going to get the probability of not getting a yellow ball. So which means that probability of getting a yellow ball, we know that there are only 12 yellow balls. So in favor to the condition, there are only 12 outcomes. Total balls, we know that it's already 34, which means that it is 12 in the numerator side and 34 in the denominator side. So in this case, we are finding the probability of getting a yellow ball, but we are asked to find the probability of not getting a yellow ball. So as per the fifth condition which I mentioned to you, we are going to get some value here. Upon simplification, this 12 by 34 is going to become 6 by 17, which you could not see because I'm here. Okay, so we are going to get 6 by 17 after simplification, but this 6 by 17 is the probability of getting a yellow ball. So if you're subtracting this 6 by 17 from 1, you are going to get it as 11 by 17. When you solve this section, you will be definitely getting 11 by 17, which is the probability of not getting a yellow ball. So we already got this value. I've only shown this for your better understanding and an easy way of doing. As far as the logic is correct, you're going to get the correct answer. So you're going to get 11 by 17 in this case. So in this kinds of problem, you can try to solve the problem in 2 or 3 different ways, but still you should get the same numbers. So you can try doing the second way to make sure your answer is correct. Okay, this is how you're going to do the problems. So this is the end of the first episode, and we'll be seeing in the next episode. So thank you. Have a nice day.